The overall goal of these experiments is to create high-quality vanadium dioxide films by atomic layer deposition and characterize the optical properties through the metal-insulator transition to produce a model describing vanadium dioxide as a tunable refractive index material.
This method can help answer key questions in the fields of atomic layer deposition and phase change materials, such as ways to promote different stoichiometries of transition metal oxides.
The main advantage of this technique is that it enables fabrication of heterogeneously integrated phase change materials that are highly conformal and uniform in composition and thickness across large areas.
Generally, individuals new to this method struggle because determining the narrow experimental parameter space for each step is key to achieving correct film properties.
First, sonicate a double-sided, polished C-plane sapphire substrate in acetone at 40 degrees Celsius for 5 minutes. Transfer the substrate to isopropyl alcohol heated to 40 degrees Celsius and sonicate for another 5 minutes. Rinse the substrate in flowing deionized water for 2 minutes and dry the substrate with a stream of nitrogen gas. Store the clean, dry substrate in a wafer container. Next, confirm that the atomic layer deposition reactor chamber is at 150 degrees Celsius. Vent the reactor with ultra-high purity nitrogen gas. Once the reactor is ready, load the substrate into the reactor, close the reactor, and pump down the reactor to less than 17 pascals or 0.128 torr. Wait at least 3